Okay, for today's little science show, let's talk about resonance. Now, the number one rule when it comes to resonance-related things is the Octet Rule. You always want to have 8 electrons per atom. So if you look at our example today, it's CO3. If we count double bonds always as 2, and then lone pairs as 2, we could see 1, 2, 3, 4, 5, 6, 7, 8, 8, and 8. That way we know we're starting off with a complete molecule, so that's good. Now in resonance, essentially what happens is electrons move around and cause other electrons to move. So if we were to move these 2 red ones to here, for carbon to keep 8, we'd have to bump off 2 electrons from that double bond. We always use double-headed arrows in resonance. And at least I personally, always like to start with this skeleton structure, so you know that this isn't going to change. This oxygen is this one, this carbon is this is this, and this oxygen is this oxygen. That never changes. And there's always going to be that single bond. Most of the time, anyway, there's a single bond that remains. So I can always go here to here and then figure it out from there. Now, based on my arrows, I know, well, that went to there. These electrons went here, and then these guys stayed the same. This retains its +1 charge, -1, sorry, and this -1 charge actually bumps up to the top. If we want to keep going with this example, again, we do our double-headed arrow, start with our skeleton structure, and think, well, what if these guys went to here? And that would bump these electrons back to there, giving us this structure. Now all these are essentially the same. You can see this carbonyl double bond just kind of makes its way around the atoms. Another thing with resonance is we like to put them in brackets. So these are all of our major contributors to the resonance structure. There is a minor contributor that I can think of, and normally minor contributors are going to have some sort of charge on the carbon, so whether a plus or minus on the carbon, and that's pretty uncommon because carbon doesn't like to have a charge. But if these blue guys were to come here, we would be left with this structure, which technically adds up to the same. It's still -2, it's still CO3, but it's a minor contributor. This would not be found most of the time. Now, if we wanted to combine all of our major contributors, essentially what it would look like is this. We'd use these dotted lines to represent partial bond character. And in essence, what we're doing is equalizing all of these into one. So 2/3 of the time, each oxygen has a minus charge. So you can put in a -2/3 on every oxygen, and you know that adds up to 2- in the end. So this is our abbreviated version of all of that. Some things to remember with resonance: always try to use the Octet Rule, always track your flow of electrons with arrows, and you can always start with a skeleton. So that base structure stays the same 9 out of 10 times, and you can use that as a guide to see where things could go. Carbons don't like charges. Oxygens are really useful in resonance because they can take or give electrons pretty easily. Same with nitrogens. that is our first example on resonance structures. Thanks for watching.